So, hello everyone. Good morning, good evening, good afternoon. So, this will be our final audiovisual lesson for this semester about statistics and probabilities. So, before we're going to start, I hope that your module is on your side and your notes, and especially your subject test. So, let's start. So in statistics and probability, let's go on to page number 6. Let's turn to page number 6. Alright, so this is our page number 6. So we are talking about chapter 5, parametric, statistical inference, hypothesis testing. So we have this code. I'm sorry we cannot cover the whole linear sheets, but I'm just giving you this chapter because it is basic in moving on to the next topic. So ito lang yung i-discuss ko as our final topic for this semester. So what is a hypothesis testing? So it is a decision-making process for evaluating claims about the population based on the characteristics of a sample coming from that population. Okay, sample, population, I know you know the meaning of that. So the decision is whether the characteristic is acceptable or not. It involves making a decision. Yes, hypothesis testing, we're talking about your decision between two opposing hypotheses, which are the null and the alternatives. So again, we have two opposing hypotheses. We have the null and the alternative hypothesis. So what is a null? So the null hypothesis, denoted by H sub O, is a statement that there is no difference. So when you say no difference, so walang kaibahan between a parameter and a specific value, or that there is no difference between two parameters. So when you say null, again, walang kaibahan. Say for example, if the null hypothesis says that the average grade of the students is 50, then in symbols we write the null hypothesis is the mean is just equals to 50. Okay? So mean, remember this is the mean population, the mean is equals to 50. Okay? So let's have the alternative hypothesis, denoted by H sub A, is a statement that there is a difference. Opposing, so null is walang kaibahan, the alternative is merong kaibahan. So between a parameter and a specific value, or that there is a difference between two parameters. When the alternative hypothesis utilizes this one, not equal, the test is said to be non-directional. Okay, so we have here three possible alternative hypotheses, which may be formulated from the above null method. So we go back here for the example. So the null hypothesis says that the average grade is 50. So we have the null here. The mean is equals to 50. So, okay. So we have the alternative hypothesis. We have 1. We have the mean is greater than 50, meaning the average grade of the students is less than 50, rather less than 50. So less than 50. Second, the average of the students is greater than 50. Okay, and the third one is the alternative hypothesis is the mean is not equal to 50. Alright, so the average grade is not equal to 50. So we don't know the direction, that's why it is called non-directional. So let's go back here. So this is what we call non-directional. Okay, that not equal is called what we call the non-directional, while these two is what we call the directional, because from the less than, which means the direction is to the left because it is lesser than, and this one is greater than to the right because it is greater than. So Another thing is this non-directional is what we call one-tailed. Yes, it's called one-tailed. And then this not equal or the non-directional is what we call two-tailed. Okay. So if we're going to have a graph or a representation of what is a one-tailed or two-tailed, so we have here alternative hypothesis mean is less than 50. So therefore, when we have here, so probably so less than man. So say for example this is 50. So that's why we have here, right? That is from the right. And if the alternative hypothesis is greater than 50, then we have here naman, okay, to the left. All right. And then if we have the alternative hypothesis is not equal to 50, so we have two sides that are going to be shaded. Later on we will discuss this one. Okay, so that's why it is called two-tailed, because two-tailed are being shaded. This is called one-tailed. This two is called one-tailed. This one, the lesser than and the greater than, is called one-tailed because there's only one tail that has been shaded. Okay, so that is a one-tailed, two-tailed, directional, and non-directional. Okay, I hope it's clear. So let's have another example. So formulate a null hypothesis and its alternative hypothesis and identify whether the alternative hypothesis is directional or non-directional for each of the following. Example: the average TV viewing time of all 45 5-year-old children is 4 hours daily. So what do you think is the null hypothesis? So it is given to you that the average time is only 4. That's why we are going to use 4. That's why we have here the null hypothesis is equals to 4. Okay? So the null hypothesis is equals to 4. So we can have the alternative hypothesis, the average time, since we do not have any direction given from the problem itself, we do not have lesser than or greater than, since we can use, remember that alternative hypothesis is 1. It should be the opposite of the null. So since it is said to be that the average TV viewing time of all 5-year-old children is 4, thus that is the null hypothesis, which is equals to 4, then the alternative can be not equal to 4. So what do you think is this? Is this a directional or non-directional? Yes, that's correct. That is a non-directional, because what we are using, one-tailed or two-tailed? Yes, we are using two-tailed. Okay, so I hope it's clear to you. The non-directional, directional, one-tailed, and two-tailed. Okay, let's have another example for this null and alternative hypothesis. So we have here are some examples. The school registrar believes that the average number of enrollees this school is not the same as the previous school. Okay, so what could be our null hypothesis here? So our null hypothesis is what? Okay, the null hypothesis could be the school registers believe the average number. So what is the average number of enrollees of the school year is not the same as the previous school. So what is the clue? Is not. So it's not the same. So when you think it's not the same, the given there in the problem actually is the alternative hypothesis. So it is not the same. So that is already the clue. Therefore, our null hypothesis is the average number. Wait, it's yes, like that. Okay. All right. So the average number of enrollees this school year is equal. Let me just let's use let say for example, let x be the average of average number of enrollees this school year. Let y be the average number of enrollees. I'm sorry, I cannot write it here. Yun na lang. Enrollees previous school year. Okay, so we are using x and y here so that it would not be long and it's easy for you to answer. So the null hypothesis could be x is equals to y. All right, x is equals to y. Alright, so we have the x and y, and please do not forget that we are talking about your average. So it could be, wait lang na, so the mean of x is equals to the mean of y. Okay, so this is just a representation of these examples here. Okay, so what do you think would be the null alternative hypothesis? We have now the null, which is the average of enrollees in the school year is equal to the average of enrollees from the previous year. Now, what do you think is the alternative hypothesis? So, since the clue is not the same, so we can use here the average of the enrollees this school year, which is the mu sub x, is not equal to the mu sub y. Why did you use not equal? Because of the word it is not the same. So that's why we use that one, because again it is what we call non-directional. Let's have example number 2. However, if the school register believes that this average number of enrollees this school year is less than the previous year school year, then we will have the same alternative hypothesis. Okay, what we're talking about here again, what's the clue? We are talking about here less than. Okay, that's our clue. So that less than, is that from the null or the alternative? It is from the alternative. So we already have the clue that our alternative hypothesis is less than. Okay, so the school year is less than from the previous years. Okay, so it is less than from the previous years. So what do you think is the null hypothesis? So we have now the null hypothesis is, again, it should be equal. So the enrollees in the school year is equals to the enrollees from the previous year. So the the alternative hypothesis is that the average of the enrollees in this school year is less than. So average in the school year, so the average is less than the average from the previous year. How about the third example? What is the clue? The clue there is greater than. Okay, so again, our null is equal, and then our alternative now is what? The number of enrollees in this school year, which is the average of x, is greater than the average of the enrollees of the previous year. So that is the difference between the null and the alternative hypothesis. So the first example is non-directional and the other two is directional. This one is, what do you think is this? This is right or left? Left-tailed or right-tailed? Yes, this is left-tailed, and this is right-tailed. Alright, so let's have another example. Alright, I'm going to move it first here. Yeah, this example will be used later on, not for now. That's why I keep removing that. Okay, let's have this example. The average waiting time of all customers in the restaurant before being served is less than 20 minutes. Determine the hypothesis and the directional test. So what do you think is the null hypothesis and the alternative hypothesis is given? What is the clue in our problem? The clue is less than. Okay? So when it is less than, therefore we know that it is less than, or we are using directional. Okay? So the average waiting time of the customer in our stand before being served is less than. So what is the average? Remember that the average is equals to 20. So our null hypothesis is mu is equals to 20, or the average is equals to 20. Never mind putting the minutes. So again, why did we use 20 here? Because that is the average from our problem. So the mean is equals 20. So what do you think is our alternative hypothesis? So our alternative hypothesis, since we have the clue that is less than, so therefore we have, we already have now the alternative. So we can use the mean is less than 20. Okay? There is also another thing you can write as a null hypothesis. So you can also have, since this is less than, so what is the opposite of less than? Greater than, right? So it could be mu is greater than or equal to 20. Okay? What do you think? Okay, the reason why we can use greater than 20 because our alternative hypothesis talks about lesser than 20. We cannot use here lesser than in our this one. In our second, yes, you can write this as your null hypothesis as long as there is an equal sign. Yes, there is an equal sign here. There is an equal sign. There you go. There is an equal sign. So it should be, should be an equal sign before you can use that one. Okay? Okay, so let me change. Okay. So again, this can be your null hypothesis, the opposite of your alternative hypothesis. Ma'am, what if we have here, what if it is greater than? So if it is greater than, so your null hypothesis would be the alternative. Since your alternative is mu greater than 20, so what is the opposite of greater than? Then your null hypothesis can be mu is less than or equal to 20, or it could be mu, what happened? There's only one. Now you can just choose between the two. Never mind using both, you can just choose between two, but be sure again that there is an equal sign for your null hypothesis, because if you forgot to write the equal sign in your null hypothesis, that could be your alternative hypothesis. So again, why do you keep on writing H? So you can have the mu is equals to 20. Okay, you can have two choices. What if lang niya? What if it is greater than? So the alternative hypothesis is greater than, thus you can have your null hypothesis is lesser than or equal. It depends again in your problem. As you can see here in our three examples, we have three different problems. There is a clue that it is not the same, there is a less than, and there is a greater than. Okay, so that is how you're going to write a null and alternative hypothesis of a given problem. So again, null hypothesis, I'm going to sum it up first. So when you say null hypothesis, there is no effect. When you say null hypothesis, there is no effect. We are going to use equal sign. Okay, we're going to use equal sign. If it is an alternative hypothesis, if it not, so there is a difference, there is an effect, or there's an significance effect. So we can use here in our alternative as not equal. remember the clue from our problem. If we can use here less than if it is below or less than. We can use also greater than if in the problem you can see above or greater than. Okay, so null alternative hypothesis is we have different direction. This equal sign is non-directional, and this two is directional. I cannot write anymore because it is directional. Okay, it's directional. Then less than is what? Less than is left tailed. Greater than is right tailed. Okay, do not forget also that the non-directional talks about that's what we call two-tailed, and directional is what we called one-tailed. Okay, I hope it's clear, and we're going to proceed to our next topic, which is the continuation of our of your last. Thank you, and see you in our next video.